Earth is surrounded by a powerful, yet invisible shield known as its magnetic field. Generated deep within the planet's core, this field stretches far into space, protecting life from harmful solar and cosmic radiation. Imagine, for a moment, what would happen if this protective barrier were to suddenly vanish. Without the magnetic field, Earth would be exposed to intense streams of charged particles from the Sun, leading to dramatic and immediate consequences. The atmosphere could begin to erode, electronic systems might fail, and living organisms would face unprecedented dangers. This scenario sets the stage for exploring the vital role Earth's magnetic field plays in sustaining life as we know it. Deep beneath the Earth's surface lies the core, a region composed primarily of iron and nickel. The movement of these molten metals generates our planet's magnetic field, a phenomenon known as the geodynamo. This magnetic field extends far into space, forming a protective shield around the Earth. It plays a crucial role in deflecting harmful solar wind and cosmic radiation, which could otherwise strip away the atmosphere and endanger life. Without this invisible barrier, the conditions on Earth would be far less hospitable. The study of the core and its dynamic processes continues to reveal insights into how our planet sustains and protects life. The sudden disappearance of Earth's magnetic field would trigger immediate and widespread disruptions across the globe. Navigation systems, which rely on magnetic compasses and satellite data, would fail, leaving ships and aircraft without reliable guidance. Satellites orbiting the planet would be vulnerable to increased radiation, leading to malfunctions and potential loss of service. Communication networks, dependent on these satellites, would experience blackouts, cutting off vital links between continents. The loss of connectivity would impact emergency services, financial transactions, and daily communications, creating chaos in both local and international operations. Radiation storms are becoming increasingly intense as solar and cosmic particles relentlessly bombard the Earth. These storms pose serious health risks, particularly to astronauts and airline passengers at high altitudes, as elevated radiation levels can damage living tissue. Technological systems are also vulnerable, with satellites, power grids, and communication networks frequently disrupted by the energetic particles. The skies may light up with vivid auroras, stretching far beyond their usual polar boundaries, but these dazzling displays are a sign of underlying danger. The combination of health hazards and technological failures highlights the growing impact of these radiation events on modern society. Over extended periods, Earth has experienced significant atmospheric loss, gradually thinning the protective layers that shield life from harmful radiation. The destruction of the ozone layer has further exacerbated this vulnerability, allowing increased ultraviolet rays to reach the surface. As a result, ecosystems have been disrupted, with many species struggling to adapt to the changing conditions. The cumulative effects of these changes have led to widespread environmental collapse, altering weather patterns and diminishing the planet's ability to support life. With each passing decade, Earth has become increasingly hostile, challenging the survival of both flora and fauna. The consequences of these processes highlight the delicate balance required to maintain a habitable environment. As radiation levels on the planet's surface rise dramatically, life becomes increasingly unsustainable. Natural ecosystems begin to collapse, unable to withstand the harsh new conditions. In response, humanity is forced to adapt, seeking shelter in underground habitats where the environment can be controlled and shielded from harmful radiation. Some communities attempt to engineer artificial magnetic shields, hoping to recreate the protective barrier once provided by the planet's natural magnetic field. These efforts represent a desperate bid for survival, as the world above ground transforms into a hostile and uninhabitable landscape. As environmental conditions shift, the question arises: could life adapt to these new realities? Evolution has shown remarkable resilience. with species developing traits to survive in extreme heat, cold, or scarcity. Over generations, organisms might evolve thicker skins, altered metabolisms, or new ways to obtain energy. Humans, too, could harness technology to overcome challenges, such as building climate-controlled habitats or engineering crops suited for harsher environments. Innovations like advanced water purification and protective clothing may become essential. Ultimately, survival would depend on a combination of biological adaptation and creative technological solutions, shaping the future of life on Earth. Magnetic field reversals are natural phenomena where Earth's magnetic poles switch places. These events have occurred many times throughout the planet's history, with the last major reversal taking place approximately 780,000 years ago. Scientists study the patterns and timing of these reversals by examining ancient rocks and sediments, which retain traces of past magnetic orientations. Despite initial concerns, evidence suggests that life on Earth has persisted through these transitions, indicating a remarkable resilience. However, during reversal periods, the magnetic field may weaken, potentially increasing Earth's vulnerability to solar radiation. Understanding these processes not only sheds light on the dynamic nature of our planet, but also helps us appreciate the delicate balance that protects life on Earth. Throughout history, humanity has demonstrated remarkable ingenuity and resilience when confronted with daunting challenges. As our planet faces unprecedented threats, the drive to innovate becomes more crucial than ever. Scientists, engineers, and visionaries around the world are working tirelessly to develop new protective solutions that safeguard both people and the environment. Their determination fuels breakthroughs in technology, sustainability, and global cooperation. With each step forward, we reaffirm our capacity to adapt and thrive. This hopeful outlook inspires confidence that, together, we can engineer a safer and more sustainable future for generations to come. Earth's magnetic field is an invisible force that quietly shields our planet from harmful solar radiation and cosmic particles. Without it, life as we know it would face immense challenges, from increased exposure to radiation to the potential loss of our atmosphere. Its silent presence is often overlooked, yet it plays a crucial role in maintaining the delicate balance necessary for survival. Reflecting on its importance raises profound questions about our vulnerability and the intricate systems that make life possible. The magnetic field's quiet protection serves as a reminder of how much we depend on forces beyond our immediate perception. Ultimately, contemplating a world without this safeguard invites us to appreciate the hidden mechanisms that sustain our existence.